trig integration using trig identities. Does anyone remember any trig identities? Yeah, the one you should all know, sine squared theta plus cos squared theta equals 1. Very good. There's a whole bunch of them. Here they are. Ta-da! The biggest tip today, if you have a cos with a power or sine with a power, we want to get rid of that power by using a trig identity. So we're going to substitute in to get rid of the power before we integrate. So, first one, we've got cos squared. We want to eliminate the squared. Before I keep going, how is this one different to the one we did yesterday? So there's no other function next to it, right? It's just a trig to a power. That's really important that you remember that. If it's just a cos function squared or cubed, or a sine function squared or cubed or something, trig identity is the key. So that's what today is all about. But if there's another function there, that's when we use the substitution method. So you're trying to look for an identity that has cos squared in it, and you want to use that to substitute in so there is no power anymore. So some of them have
we got cos 2a equals cos squared a minus sine squared a.
Cos 2a equals, so we could rearrange this, but then we'd still have a sine squared. So try a different one. Okay, so that looks like the winner. Except we just need to get the cos squared by itself. So we add 1 to both sides, and then how do I get rid of that 2? Divide everything by 2. Okay, so I rearrange that one to get cos squared a by itself. So I'm going to substitute that in, and it's going to be easy to integrate because there's no powers. That in, so it's 2 times x over 4 plus a half dx. We can bring the half out the front, right? And what's this 2x4 become? X over 2. So what is the integral of cos x over 2? So we know it becomes positive sine, and the half becomes a 2 out the front. Does everyone get that? Because we divide by a half, which is the same as 2. And what does the 1 become? Don't forget on the end, plus c.